Okay, so let's look at this function for a minute. Not this one. We decided this one is a exponential function because we see a common factor. And what do you guys see as a common factor? Times 3. Okay, times 3. And can you see the output when we put 0 in? Okay, so it's the y-intercept, I suppose we'll call it. I don't want to call it b, and you'll see why here in a second. So we know for a linear function, it's y equals mx plus b. If we know the common difference, right, and we know the y-intercept, we can write the equation. Well, for an exponential equation, we can do the same thing. We just have to know this function right here, y equals a times b to the x. Okay? Now remember, a is one of these two things, and b is one of these two things, and I suppose the y-intercept, just to make things as complicated as possible in this equation, the y-intercept is a, which is super weird since y equals mx plus b. You've always learned that the y-intercept is b, haven't you? Well, math can't be easy, can it? So in this case, the y-intercept is a, and then the common factor is the b to the x. Sometimes we have a thing in us that makes us want to say this is 27 to the x. But what comes first, exponent or multiplication? Exponent. So when you do this, you have to raise 3 to that exponential power first, and then multiply it by a every time. So this would be the equation that would describe this particular function right here. So if you can figure out the 0 term, what you get out when you put 0 in, and you can see the common factor, you can write the equation for an exponential function or an exponential series. So if I give you a series that's exponential, like 2, 4, 8, 16, something like that, is this we call it a geometric series or an exponential series? See the common factor? Okay, so the common factor is 2, so that would be b. The common factor is 2. And you see, remember, whenever we look at a series like this, we say this is term number 1, term number 2, term 3, term 4. What is term 0?
1.
It's 1. Be very, very careful. It's not 0, is it? It's 1. So see how we're dividing by 2 each time we go backward the other direction? So this one would be y equals a, which is the y-intercept, 1, times the common factor to the x power. Or probably we would just write it like this. We wouldn't write the 1. We're too lazy for that. But you always got to remember that even if you see an exponential function like this, it really means 1 times 2 to the x. Okay? And just for a review, there's some limits on a. Like there's some things like, can a be a 0? No, it does not make any sense to have a be a 0. So in this function, a does never can equal a 0. It can be a negative number, which is weird, but we don't look at it much, but it's not 0. And then there's some things about b as well. Do you guys remember?
It can't be a 1.
Can't be a 1. Why not?
Because then it would just be a linear function.
Right, so b cannot equal a 1 because it would just be a linear function. 1 to any power still 1. It would just be a horizontal line is what you would end up with, right? Were there any other things about B? It had to be greater than 0. Could it be 0? It's got to be greater, right? Okay. So that common factor's got to be greater than 0. And then let's just think about this for a minute. When B is between, so on the number line here, here's 1. When B is in this area, you're going to get a function that decays, that gets smaller and smaller and smaller and smaller. You're going to take half, and then half, and then half, and then half, and then half, and so on. If B is greater than 1, if it's up here, then you're going to get what we call exponential growth, where, like this. See how our common factor here is 2, greater than 1? See how it's growing, 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 growing? So these two functions, one will look like this, exponential growth. That's when B is greater than 1. The other one will look like this. It'll if I can remember how it comes down here, exponential decay. So we start big and get smaller. That's when B is less than 1, but still greater than 0. So if you don't have this written in your notes, and this labeled, what's this one? What's the A stand for? The initial amount, the starting point, the y-intercept, and this is the common factor, right? Make sure you have those labels so you remember that. So that'll help us write. So if we have a series or if we have a table, we can write the exponential equation from that.